All right, what's up, everybody? How are we doing? Welcome to the third lesson overall of the school year, second lesson of geometry. Last lesson, we learned about definitions, basics of geometry. We learned about lines, line segments. We touched a little bit about angles. All right, so today's lesson, we're going to be going more in depth to angles. If you can, you can pause the video, do this quick do now, all right? Just refresh. Two questions. Is this angle acute, right, or obtuse? And what is the measure of a right angle? So go ahead and pause the video. Great. Hopefully you answered those. Okay, if we take a look, this angle over here is 130 degrees. It is more than 90 degrees, so that means it is an obtuse angle. Shout out to Mr. Stanton's amazing handwriting. What is the measure of a right angle? We know that right angles are always 90 degrees. Cool. All right, our objectives of today's lesson, we will be able to name, draw, and identify complementary angles, supplementary angles, adjacent angles, vertical angles, and linear pairs. All right, so like I said, a lot of angles today. We're still going to be working a lot with definitions, but we're also going to be working some math in that with these definitions as well. Okay, angle reviews. All right, if you were able to download the set of notes here, if I escape out of here, all right, I have the notes over here. All right, angle review, the 4 types of angles that we learned about last lesson. Go ahead, you should write down what the definition of those angles are. Remember, an acute angle is any angle that is less than 90 degrees. This is your acute angle here. A right angle is exactly 90 degrees. It always has this little box in the corner. Obtuse angle is more than 90 degrees, and a straight angle looks basically just like a straight line, and it always measures 180 degrees. Okay, when we measure angles, we say degrees, right? Degrees is the unit used to measure how big or small an angle is. Right? An entire circle is 360 degrees, and this little circle right here is the symbol that we use to say degrees, so that way you don't have to write out the word degrees every time. Okay, before we begin, as a teacher, I really like to just give you guys a problem, even though you haven't learned the material necessarily, and just see what we can do, okay? And usually it's things that I believe that you can truly figure out on your own without my assistance, okay? So go ahead, pause this video, think and try and find the measure of what angle Z is, right? Think, angle Z creates a straight line here, right? Angle Z plus angle 120, that makes a straight line. And if we keep in mind the definition of straight angles, what can we think that angle Z is going to be? Pause, work. Cool. What did we get? Okay. All right. I hope that you got the answer that it is 60. Know that straight angles measure 180 degrees, right? So if this was one angle, right, we know that this entire thing is 180 degrees. And if this is 120, right, we know that 120 plus what this used to be angle Z, right, whatever angle Z was, it had to add up to equal 180. Well, if we're solving for Z, right, this is where our algebra skills come into play. To get rid of positive 120, we would subtract 120. Those cancel out, and we would get that Z, that's a Z, equals 180 minus 120 is 60. So we know that this angle that used to be angle Z should measure 60 degrees. Okay, now, well, if you know that this is 60 degrees, find the measure of angle K. Again, right, this now makes a straight line, right? Think, now this is a straight line that measures 180 degrees. If this is 60, what must be K? Okay, you should get 120. It has to add up to equal 180 degrees. It's a straight line. Okay, notice how the two angles over here are the same, right? This is 120, this is 120, all right? This is basically what we're learning today. Okay, so now we're actually getting into it. Again, if I escape here and go over to your notes, right? Here's your first definition. Adjacent angles, you can write the definition here on the line. If you printed it out, write it out. If you downloaded it, you can type it out. Okay, adjacent angles, angles that share a vertex and share a ray, right? We can also think of this as angles that are touching each other. This second part is definitely not a mathematical definition, but it's a good way for you to remember it. Okay, so these are a pair of adjacent angles, right? If we look, angle P0Q, not 0, O, also terrible drawing straight lines, right? Angle POQ, and if I change colors, angle QOR, right? They are touching each other. They share a vertex. They both share the vertex 0, or sorry, I keep saying 0, OQ. They both share a ray OQ, and they share the vertex, which is point O. Right? They are touching each other. These obviously are non-adjacent angles. They are not touching each other. They do not share a vertex. They do not share a ray. I apologize for this terrible writing, but honestly, you got to get used to it because I am terrible at writing with a mouse. Sorry. Okay, next set of types of angles that we need to learn. Next definition, complementary angles. Know that complementary angles are angles that add up to 90 degrees. Okay, they do not have to be adjacent, or they do not have to be touching each other. It can theoretically be more than two angles. Okay, excuse me. All it is just angles that add up to 90 degrees. Okay, so here's some complementary angles. They add up to 90 degrees. These are adjacent. Notice they share a vertex. They both come to this point, and they share a ray. Okay, 60 plus 30 adds up to 90. So these are adjacent and complementary. These ones over here are complementary because it's 40 and 50. 40 plus 50 equals 90, but they are not adjacent because they are not sharing a vertex, right? They are separated, but they are still complementary. And also remember, it can technically be more than two angles. So let's say we had three angles here, right? As long as these would add up to 90, let's say this was 20. Let's say this one was 10, which means that this one would have to be 60. 60 plus 10 plus 20 does add up to 90. So that is also an example. Maybe write that on your paper. If you're typing, it's obviously hard to type that, but another example of complementary angles. Okay, so when we find the complement, right, know that complementary angles means that it adds up to 90. So if you are given one angle measure, you can automatically know what the complement is because you know that whatever it is, it has to add up with this previous number to give you 90. All right, and the way that you can find the complement, you're always going to do 90 minus the given value, and I'll show you why. Okay, remember, complementary means adds to 90. So if you have two angles, right, this angle plus this angle has to equal 90, right? And if we take this first example, 21, if the first angle is 21, we don't know what this second angle is, but we know that whatever we add it with 21 has to give us 90. And if we're just solving, let's say instead of this question mark, we have a variable x. Now we have an equation, 21 plus x equals 90. Well, to find x, we subtract 21. And setting up an equation like this shows us that we end up with finding the complement is just 90 minus the given value. 90 minus 21, which was our given value. And 90 minus 21 would be 69, right? Let me double check. Okay, so that means for this one, the complement to 21 is 69, right? the complement to 56, right? We know that we have two angles. This angle plus this angle has to equal 90. Okay, this time I'll use a different color. If we're talking about 56 plus x or question mark or whatever, right? To find x, we would have to subtract 56. Those would cancel. And 90 minus 56 would give us 34. Let me just double check my math. Right? Feel free to use calculators. That's totally fine. 90 minus 56 is indeed 34. So we know that the complement here is 34. Okay? So this is why it's 90 minus the given value, because if you set up an equation like this, right, you will just end up subtracting. So go ahead, pause the video. You can just subtract these values from 90 and you'll get your complement. Okay, so this one, 90 minus 70 would give you 20. 90 minus 44 would be 46. 90 minus 36 would be 54. And 90 minus 87 would be 3. So these are all complements because if you add them together, they will always add up to 90. All right, complementary angles. Now, supplementary angles are angles that add up to 180 degrees. Again, these do not have to be adjacent or touching each other, and it can be more than two angles, right? But they just have to add up to 180. Okay, so we see that 120 plus 60 does give us 180. Notice these are both supplementary and adjacent because they share array and they share a vertex. Okay, these are supplementary because 40 plus 140 gives us 180, but they are not adjacent. Okay, they are not adjacent. They are not touching each other. Okay, so it's the same thing. Right? If we find the supplement, find the supplementary angle. The supplement is the other angle that adds up to give us 180. Okay, so again, same thing. If we have two angles, this blank angle plus whatever this blank angle equals 125. Sorry, that is totally wrong. If it's supplementary, it has to add up to 180. Okay, and our known angle is 125. Sorry about that. And it's the same thing. We have an unknown. You could use a question mark, right? You could use an X. It's the same thing. To solve for X, we need to get rid of 125. So we subtract 125 from both sides. Those cancel. 180 minus 125 would give us 55. So X equals 55, or that other angle would be 55. And again, let me just double check my math. Yep, adds up to 180. Okay, same thing. 37 plus whatever that other angle is has to add up to give us 180. So we would subtract 37 from both sides. Those cancel, and 180 minus 37 gives us 143. So that unknown would equal 143, and that is our supplement. Okay, go ahead, pause, work through these on your own. Just take 180, subtract the value. So 180 minus 113 gives you 67, right? 180 minus 152 gives us 28. 180 minus 95 would give us 85. And 180 minus 64 would give us 116. All right, so that is how we find the supplement. Have to add up to 180. Okay, now linear pair. Linear pair, you might find yourself thinking like, oh, this looks a lot like supplementary angles, but it has to be two things, right? A linear pair is two angles that are both, has to be both supplementary, add up to 180 degrees, and adjacent. They have to be touching each other, right? So notice they share a vertex and they share a ray and they add up to 180 degrees. Excuse me. Now, vertical angles lie on opposite sides of intersecting lines. Okay, opposite sides, and the intersecting lines must be straight. Okay, they are always congruent. Okay, we haven't quite talked about congruent yet. We'll talk about it a little bit in the next lesson. Okay, but congruent means that they are same shape and same size, right? The non-mathematical definition of congruent means that they are equal to each other, right? But congruent in actuality, the mathematical definition means same shape and same size. So if we look, angle A and angle B, they are on opposite sides, right? Opposite sides of intersecting lines. Okay, notice the lines must be straight. Here, these are vertical angles because the lines are perfectly straight. Notice here, this line right here is not perfectly straight. So these are not vertical lines or vertical angles, I'm sorry. C and D will not be congruent to each other. Okay, and if you think about it, we learned that previously when we were up here, right? They're across from each other. They're equal to each other. They are the same. Where are we at now? Vertical angles. Okay. So next we got some examples, right? Are these determine whether the labeled angles are vertical, a linear pair, or neither? So go ahead, pause the video, think to yourself, answer vertical, linear, or neither. Cool. Angles 1 and 2. Let's take a look. Are they next to each other? Are they adjacent? Are they touching each other? Yes, they share this vertex and they share a ray. Okay, so we know that they're adjacent, but notice adjacent isn't one of our options. Do these create a straight line and measure 180 degrees? Absolutely. So this is going to be a linear pair. Okay, angles 3 and 4. Are they next to each other? Are they adjacent? No, they are not touching each other, right? They do not share a ray. Are they opposite of each other? Yes, they are. They are on opposite sides. Okay, so that makes us think maybe they're vertical, but is this line right here a perfectly straight line? No, it is not. So that ruins it. They are not vertical angles. These ones are neither. Okay, over here, last one, angles 5 and 6. They're on opposite sides. We're on to a good start, right? Are these lines straight? Yes, they are. Straight lines, opposite sides. These are vertical angles. Shout out to the writing. Okay, how to find missing angles. There's 3 steps, 3 things that you need to do. And again, I'll show you again. Hopefully you've been keeping up with your notes, right? We are now on to the back side, right? We've already done this. We've done this here, right? Find missing angles. These are the steps that you need to take to find missing angles. Step number 1, think first, what type of angles do we have? Do we have complementary, supplementary? Is it a linear pair? Are they vertical? Once you know the answer to that, then think, well, what is their relationship? Does that mean, are they adding up to 90? Are they adding up to 180? Or are they congruent, which means they are equal to each other? Then the last step is to set up the equation and solve. Okay, so write those down in your notes, and then we're going to do some examples. Okay, so find the missing angle. Find the measure of angle RSU. Okay, RSU, that is this angle right here. All right, so first we need to think 1. I'm going to write down the 3 steps. Okay. Step 1, what type of angles do we have? Linear pair, supplementary, complementary, vertical. Okay. Well, we see that this here is a straight line. So that makes me think 180 degrees. Okay. Are they touching each other? Yes. This here is a linear pair. All right, second step. Okay, now that we know it's a linear pair, what does that mean? We know that a linear pair has to add to 180 degrees, right? Has to add up to 180 degrees. Step 3 is set up your equation and solve. Well, again, all right, the reason why I write this out is because we are going to transform our words into an equation. We know that the two angles that we have, if we add them together, it has to add up to equal 180. What is the angle that we have here in blue? 62. What is the angle that we don't know? We don't know. All right. Put an X there, whatever. How do we get rid of 62? If this was an X, here, I'll change it to an X. 62 plus X has to equal 180. So we get rid of 62 by subtracting. Those cancel, and we get X is equal to 180 minus 62 would give us 118. So that means that the measure of our SU equals 118 degrees. Boom. Okay, next one. Find the measure of angle 1, angle 2, and angle 3. Okay, first, let's make our lives easier. Let's go with angle 2 first. Okay, if we go with angle 2, what type of angles do we have with 35 and 2? They're on opposite sides, and we have straight lines. So the first thing, we know that these are vertical. We know that vertical angles means that they are congruent. And congruent is another way to, if we're going to create an equation, that means they're equal to each other. So if this angle is 35 and angle 2 is equal, we know that angle 2 is also going to equal 35 degrees. Okay, if we take another color, right? So we can, here, well, let's label this. This is 35 degrees. Okay, now if we look at angle 1 here, now, let me erase this blue line. Now we see that we have a linear pair, right? Or supplementary angles. This angle 1 plus angle 35 has to equal 180 degrees. So that means angle 1 plus 35 has to equal 180. The way that we find the measure of angle 1 is subtract 35. Those cancel, and we get angle 1 is equal to 180 minus 35 would come out to 145 degrees. So we know that this is 145 degrees. And now we can take a look at angle 3. Remember, now these, if I erase this line and use a new color, let's go with green. Now we see that these two are vertical. If we've already found this one, we don't even have to do any math. We just automatically know that this one is 145. Okay, good. Okay, now we're getting trickier. Okay, now it's not just numbers. We got some X's. We got variables now. Okay, so the rules still apply, right? Rule 1, 2, and 3. Rule number 1. Think, what type of angles do we have here? Well, these are on opposite sides. They have straight lines. These are vertical angles. All right, rule number 2 says, what is the relationship? Now that we know that they're vertical, we know that the relationship of vertical angles means that they are congruent, which means that they are going to end up being equal to each other. Okay, step number 3, we set it up. We know that they are equal. This angle is equal to this angle. So again, we have two angles, make two lines. But now, instead of adding things together, since they're vertical, we know that they're equal to each other. On one end, we have 96. And then on the other end, we have an expression, 2x plus 6. All right? Nothing has changed here. We still have vertical angles. that are equal to each other. It's just that we don't know what x is. So we have to put in the entire expression. Now we have an algebra problem and we solve. 2x plus 6. So get rid of everything on the same side as the x. We need to get rid of 6. We subtract 6. Those cancel. We have 2x equals 96 minus 6 gives us 90. How do we get rid of 2? 2x means 2 times x. The opposite of times is divide. So we divide by 2, divide by 2. Those cancel, and we get x is equal to 90 divided by 2, which is 45. Okay, remember, this is what x is equal, not what the entire angle is. Okay, so we know that these are vertical and they must equal each other. Let's plug in to check and solve. 45 is x, so that means if we want to check 2 times 45 plus 6, well, 2 times 45, we figured out is 90 plus 6 equals 96. Notice they are the same. They are congruent. Okay, now this is getting really tricky, right? Find the value of t. We'll go blue this time. Same rules apply. Rule number 1, what types of angles do we have? Well, we see that they share a vertex and they share a ray. We see that they create a straight line, right? We can call these supplementary. I'm just going to put sup because I'm terrible at writing, right? Supplementary. These are also a linear pair, and I'm just going to put LP for linear pair. Both of these, what is the relationship? Rule number 2, they add to 180 degrees. Okay, so now 3, set up the equation and solve. It's the same thing. We have 2 angles, right? 2 angles, and we know that they have to add to equal 180. All right, if we use a different color, right, one angle is 15t. I hate using t because it makes it look like a plus sign. It's okay. The other angle that we have here is 20t plus, I'm running out of room, I'm sorry, plus 5. Okay, so I'm going to rewrite that now. Our entire equation is 15t plus 20t. I'm trying to really make a difference between t's and pluses, plus 5 equals 180. Now we can solve, right? I just took the two angles, plugged them into our equation. Combine like terms. 15t plus 20t gives us 35t plus 5 equals 180. Got to get rid of all things by the t. Plus 5, the opposite is subtract 5. Those cancel. We end up with 35t equals 180 minus 5 gives us 175. All right, to get rid of 35, we divide by 35 to both sides. Those cancel. T is equal to, and again, use a calculator, that's fine. 175 divided by 35 gives us t is equal to 5. Okay, and again, we could check. If we plug 5 into t, 15 times 5, that means this entire angle is 75 degrees. If we plug 5 into t, that's 20 times 5, which is 100, plus 5 is 105. Does 105 plus 75 equal 180? Of course it does, right? So we know we got it correct. Okay, another question. This one's not on your notes. I don't believe this one is on your notes. Sorry. Okay, still same thing. We got this. We can do this. Okay, rule number 1. First, find what is the relationship. We see boom, this box right here always tells us these are complementary angles. I'm just going to put complementary angles. Rule number 2, what does complementary angles means? We know that they add to 90 degrees now, which means rule number 3, we know that these two angles, right? We have two angles, one angle plus, because it's add, the other angle has to equal 90 degrees. All right, this angle here, x plus 4. This angle here is 3x plus 2. Okay, now we need to solve. Combine like terms. X plus 3x is 4x. 4 plus 2 gives us 6 equals 90, right? If we draw our line by our equal sign, right? 4x plus 6 equals 90. Get rid of plus 6, which is minus 6. 4x equals 90 minus 6 gives us 84. Get rid of 4. 4x means 4 times x. Opposite of times is divide. X equals 84 divided by 4 is 21. Okay, good. Those are your examples. Here are some extra resources. Okay, here's a new Khan Academy video. You can click on this link. Remember, these links aren't live, obviously, in the YouTube video. You need to go into Canvas and click on the actual PowerPoint slides themselves and click on these links in Canvas. But click on this link. It'll take you to a Khan Academy talking about complementary, supplementary angles. Here's a video link, Khan Academy, to vertical angles. And then here's just some practice problems if you want to get some extra practice. Other than that, I will see you in class. Have a great day. Go Mustangs.